Welcome to the deep dive.
Hey there.
So today we're digging into something that connects, well, forests and climate change
Wait.
with maybe surprisingly college-level math.
That's right. We've been looking at a source that focuses on forest carbon sequestration.
You know how forests pull carbon dioxide out of the air and store it?
Exactly. But the interesting angle here, the thing the source really points out, isn't just how much carbon they store overall.
It's about the rate, isn't it, how fast they're actually doing it?
Precisely. The speed of sequestration. And the source connects understanding that rate very directly to mathematical ideas.
Specifically differentiation. And I think integration gets mentioned too.
Yeah, those core calculus concepts.
Okay, right. So our mission then for this deep dive is to figure out why. Why does this source link the speed forests absorb carbon to, well, differentiation, calculus in the woods?
Well, the source frames it within differentiation in forest resources technology. So it's presented as a really practical tool.
Not just theory.
No, not at all. It's about analyzing how forests actually work dynamically.
So if you're maybe studying forestry, looking at how things like, I don't know, tree types or logging practices affect carbon,
hmm
you need this math.
That's the idea. I mean, think about what differentiation is fundamentally.
Uh-huh.
It's the math of rates of change, right?
Uh-huh.
How quickly something is changing at like one specific instant.
Okay, yeah. Like knowing your car's speed right now from the speedometer, not just the average speed over your whole trip.
Perfect analogy. So if you can describe the total carbon stored in a forest over time with a mathematical function,
Which I guess foresters try to do.
they do, then applying differentiation to that function gives you its derivative.
Right, the derivative, I remember that.
And that derivative is the rate. It's the mathematical way to express the instantaneous speed of carbon sequestration at any point in time.
Okay, so the rate is the derivative. That's the core link the source is making.
Mhm.
Differentiation gives you the tools to calculate that speed. But why is knowing the rate so important? What does that tell you that just knowing the total amount doesn't?
Oh, it tells you a lot about the process. A young, fast-growing forest, for example, might have a really high rate of sequestration right now.
But maybe not that much total carbon stored yet compared to, say, an old-growth forest.
Precisely. And that old forest might have a slower rate now. Understanding the rate helps predict future storage. It tells you how the system is behaving.
I see, so it's more dynamic.
And if you know the rate function, the derivative, you can sometimes use integration, which is like the reverse process,
Right.
to work backwards and estimate the total carbon accumulated over some time period, which is also, really useful information.
So differentiation helps understand the speed, the current behavior, future potential. Integration can help figure out the total accumulation from that speed.
You got it. It gives you that kind of microscopic view of the dynamics. It turns observation into quantifiable rates.
And this isn't just like a neat academic thing. The source implies this is crucial for actual forest management.
Absolutely. It's the difference between saying this forest holds X tons of carbon and saying this forest is currently adding Y tons per year, and here's how that rate might change. That detail matters for modeling, for decisions, for climate assessments. It's fundamental in forest resources technology.
That's actually pretty cool. It takes abstract math, finding derivatives, all those rules, and makes it directly relevant to something tangible, like how a forest breathes, essentially.
hmm It shows how these mathematical tools give us real, measurable insights into complicated natural systems. They're not just equations.
So wrapping this up then, this deep dive confirms what the source suggested, understanding the rate, the speed of forest carbon sequestration. That's fundamentally tied to differentiation.
Yeah, and it's a key part of what they call differentiation in forest resources technology. It's applied calculus, basically.
It really drives home how these mathematical concepts of like differentiation and integration aren't just stuck in textbooks. They offer real, concrete ways to understand complex environmental stuff.
Definitely. They give us that quantitative lens we need.
Makes you wonder, doesn't it? What other abstract math concepts are quietly helping us measure and understand the dynamic world all around us? Something to think about.